capital Y E I omega t minus v plus no minus a times z particular, which is capital Y E I omega t minus v equals capital R E I omega t minus. So take a moment. Oh, let's do. We're going to divide everything out by E. Nope. Yeah. I don't know. Wait, where?
I mean, like up here, are we going to lowercase right now?
No, these are big ones. They may not look big, but they are big. So. Those are capital Y's. Yeah. Okay. So look at what we've got. I'm going to divide by E to the I omega t minus v. And what we should do is we're going to write for E I omega t minus v not 0. I can come up with I omega capital Y minus a capital Y equals capital R. Solve for y, so I'm going to factor the y, capital Y, I omega minus lowercase a equals r, and we can write that capital Y is capital R divided by I omega minus a. Holy smokes. Guys, I kind of feel you're going to hate me in a moment. Yeah, I don't know if you don't already. What was that? So, I have an idea. I'm going to save the reason for which you'll hate me until probably later. Let's just try this. Yeah.
What is capital Y?
It's that coefficient. Remember, it's this. So remember when we had e to the ct, we said, well, let's just put a coefficient in front of it, because then we know it'll fit the solution. This is that coefficient. It just now, it's a complex coefficient. It's a complex coefficient. All right. Let's try a problem. Suppose oh no, don't write that. Don't write that. Sure. Here, we can go. We're going to do this one. Yeah. It is. Yeah, pi is 7. So A is the real component and omega is the imaginary.
You got it.
And let me not get a bad problem. Hold on. So, here we go. So, y prime minus 4y equals cosine 3t plus sine 3t. Yeah. Okay, what's our first step? Our first step is over here. Let's go back. So 1. And let's do this. Write q of t as r cosine omega t minus. Okay, so we can do that. Yeah.
Why do we jump from Y's to Z's and then forward to?
Because we're looking at a complex one. Here, this is the real function, y. But we're solving this complex one. Because this is a complex number here, or an exponential function, and then we're going to come back to y to remember that. Yeah, it's going to be a process. I promise. I promise. Long one. R. So we said that R is the square root of the 1 right here and the 1 right there. So it's 1 squared plus 1 squared square root. So it's these ones right here. This is my A. And we also need to figure out what phi is. Phi, we said, we can find phi is the tangent of phi is equal to v over A. So let's write that. It's the next step. So we can say tangent of phi is 1 over 1. Oh, trig review would give us that phi is what? Pi, there's a pi. It's pi over 4. It's pi over 4. Okay. All right. So I think we're ready. So we've done that. So I can write y prime minus 4y equals square root of 2 cosine of omega t minus pi over 4. I'm laughing because we're down to like 6 minutes left. And it's, I think, gonna take 16. Or at the rate I'm going, if we have to go fix things, it could take 60.
Just stay behind.
Yeah, we'll just camp out. It's already dark out. I just want to have marshmallows. Sip. 2 is so what we're going to do is we're going to be solving this problem. Z prime minus 4z is equal to the square root of 2e to the I omega t minus I over.
Where are omega there? Could we substitute that for 3? Or is that not?
Oh, you're right. It is 3. I'm sorry. Good catch. Yes, this is 3. You know that should be a 3. Oh my God. 3. 3. Thank you. 3. 3. There we go. All right. Now, this is what we want to do. We know this. We know we want. So we want to find our z particular, and it's going to be in general. It's going to be the form of some capital Y e I 3t minus pi over 4. And I'm going to write comma and y. That's a capital Y. Capital Y equals 1 over, let's use what we found over there, I omega minus A. I omega minus A, but that's equal to 1 over, and now we plug in our numbers. We want to plug in our numbers. So omega was 3, isn't it? 3, so I'm going to write 3i minus A is 4 in this case. Yes?
That'd be r on the top, which would be root 2.
And yes, you're right, there would be an R. That's what this line was, I was shorthanding, square root of 2. Yeah, this would be an R. That's the formula, or that's the form of it. That's with our specific number. Okay. Now we can find it. Z reduced is equal to, we have, no, actually, let's stop for a moment. Because we have a problem, do you remember what the problem was? The problem was division of complex numbers. Because like, if I asked you what the real component of this problem is and what the imaginary component are, you can't identify them in this form, right? It's not a natural way to identify them. So what you'd want to do is you want to put this so that the real portion is in the numerator, or so that the denominator is all real numbers, and then the complex number is only in the numerator. And so do you remember what we did to do that? We multiplied by the complex conjugate. So let's take a moment, and we're going to multiply them by a negative 3i minus 4 and minus 3i minus 4. And so, in other words, my capital Y is equal to the square root of 2 times minus 3i minus 4 over, and then if you distribute all this out, it should give you 9 plus 16, or 3 squared plus 4. What is that, 9 and 6? 25. Is that right? So square, I'm going to just, let's just write it this way. I have negative 4 square root of 2 minus 3 square root of 2 over 25. Okay, 1 minute, I'll show you how to write this. So our solution, I'm going to write z particular is this whole piece. It's minus 4 square root of 2 minus 3i square root of 2 over 25 times, I'm going to write it this way, parenthesis, let's expand this. This is, this e to the I is cosine of 3t minus pi over 4 plus I sine. Parentheses, 3t minus pi over 4. Okay, but where's our solution? Is our solution imaginary or real? It's real. So our answer is the real component of z for t. And I'll tell you what, we're going to stop there. We're going to write it. I'm going to ask someone for this piece tomorrow, Wednesday, and we'll pick up with this. I've assigned the homework already, so for section, this is section 1.5. So go ahead and just start the homework. We'll go as far as you can, and then we're going to finish this, but you should be able to get through a good bit of time. No. All right. Thank you for your patience.